So on the unit circle, we did have a bunch of answers that we saw. So let's first review the answers that we see. Obviously, they could be positive or negative answers, okay? So these are outputs for sine theta and cosine theta. So I'm just kind of writing these down as like a warm-up. Really, we could even call it y equals and y equals if I'm going to use the word output. So outputs are the answers that we're going to get when using the unit circle. Obviously, we can take the sine or cosine of many, many angles. The answers will not always be the same values, okay? So outputs for sine theta and cosine theta when using the unit circle. All right. Say it again. Well, if we look at it as a function, instead of looking at it as like the xy pair, you're right with the ordered pair aspect of it. But if I say to you like your age is something in a formula, this is something in a formula, I could really say f of x equals whatever I want, you know, like anything. So if like my function is sine of theta, then my answer output to my function is what I get when I calculate the sine of a certain angle. So that's just sort of separate there. But you're not wrong. I mean, if we want to call it x and just look at it that way, we can. It's just arbitrary. It'll make more sense when we're graphing trig. Did you guys graph trig at all last year? Sine waves and cosine waves? Yeah. A couple of you? So it kind of makes more sense there when you collect all those output values, but one thing at a time. So the outputs we saw are 0 and 1 are the biggest. Obviously, positive and negative doesn't really apply to 0. So I'm just going to write it kind of like in set notation just to make a list. And then we had a few other numbers. The small, the one I keep referring to as small, was what value? 1/2. Medium is good. And large was, thank you, radical 3/2. So those 5 answers are the ones that we keep seeing over and over again. Now, what else we have? Whatever you want to, I don't know how bright this color is going to be. It's kind of like, that's extra small. Yeah, that's a little too neon. Extra small, all right, small, medium, large, and extra large. So these are the sizes, these answers. Those are the small and the medium. I'm sorry, the sines and the cosines. Those are what are going to help us make everything else. So what do I mean by that? If we know the sine or the cosine of something, you can figure out the tangent, you can figure out secant, cosecant, and cotangent. Sine of an angle, we talked about yesterday, well, that's opposite over hypotenuse, or it's the y value on the unit circle. And again, the unit circle is just there as a trick, a cool way to get our answers quicker. Cosine of theta, it's really representative of the ratio adjacent over hypotenuse, or it's the x value on the unit circle. Okay? From here, tangent. Now, tangent in geometry was TOA. It was opposite over adjacent, right? There's no more values left on the unit circle. But let's think about the circle again, the one that we saw yesterday. I'll even pull up this picture over here, right? So yesterday we made this picture. Tangent is normally, if I look at this triangle that I'm tracing out right here, here's an example of a triangle, right? Tangent would normally be opposite, this side right here, over adjacent, which is this side right over here. Can we all see where I'm highlighting? Opposite over adjacent. But what did we just say this is on the unit circle? What is it? Well, in this one it's a half, in this one it's rad 2/2, and this one's rad 3/2. What did I hear from the other side of the room? Y. It's the y. What else can I say it is? Would you just tell me y is? Y is the sine. So opposite over adjacent can also be considered, instead of it being opposite over adjacent, if I know sine and cosine, I could tell you that tangent is good, sine over cosine. So if you just know the sines and cosines, we're going to use them to figure out other things. So we can say it's equal to the sine over the cosine. Some people call it y over x. I'm not a big fan of calling it that. Now, if I wanted to do like a little side extension on that, another thing that you could think of is sine is really opposite over hypotenuse, right? And cosine is really adjacent over hypotenuse. When you divide a fraction by a fraction, what are you really doing? Sure, some of us call it keep, change, flip. Is that what you're going to call it, Maria? Or multiply by the reciprocal. Exactly. So both of those are fine. I would rather say multiply by the reciprocal, but keep, change, flip is what a lot of people learn. Keep means you keep the numerator the same. Change means you change your division into multiplication, and you flip your bottom one, so that becomes hypotenuse over adjacent. It tends to get a little cloudy when your bottom is something like 2, and people feel like, oh, I'm flipping it up and it's going to become 2 over 1. Your phone is on your desk. You're clearly just texting away. It's supposed to be back there. Do you want a 0 for that grade, or are you going to put it away? Thank you. Hypotenuse crosses out, and you're just left with O over A, which is TOA, opposite over adjacent, okay? Opposite over adjacent, done right there. So it does prove that it works. Multiply by the reciprocal is the exact same thing. So either way is fine. Other side thing that I always feel necessary to point out, if I say opposite over hypotenuse divided by, I could do this, right? Adjacent over hypotenuse. You guys have always been taught like keep, change, flip, or multiply by the reciprocal. But really you could, just like multiplication and you can multiply across, you can just divide across. What's opposite divided by adjacent? Well, that's just opposite over adjacent. What's hypotenuse divided by hypotenuse? That's just 1, right? Anything over itself. So really you get that same answer of opposite over adjacent. But no one really shows that because not everything divides evenly, but it is still true. Okay, so here we have tangent is opposite over adjacent, but what we really want to know is that it's sine over cosine. Sorry, that's going to be really important and come in really handy, okay? So I like to remember that S and T are next to each other in the alphabet, so tangent, sine's on top, okay? Don't forget that. Now the next one, I'm going to do tangent. Next is cotangent. I'm going to put the co function right after it. Now cotangent is adjacent over opposite. So what do you think we could say cotangent is equal to? Good. Cosine over sine. That's fine. Cosine over sine. That's perfect. So this ratio, which is still also the x over y, is equal to cotangent. Again, if you have the unit circle and you basically memorize small, medium, large, and you memorize the ones and the zeros, and you know where the angles over 6, 4, and 3 all land, well, now we can quickly figure out tangent and cotangent, and I'll even give you a trick for memorizing them. The relationship between these two, tangent and cotangent, they are reciprocals of each other. That means they're flipped. And they're cofunctions. That's just this co in front. Okay, next. Sine and cosine, tangent and cotangent, secant and cosecant. What was secant's ratio? I had a worksheet for you guys. We worked out the ratios of all of these. Do you remember which one secant is the reciprocal of? Which one was it? Cosine, good. S and C go together. They're not with their letter buddy. So what's the reciprocal of cosine, Brandon? If cosine is normally adjacent over hypotenuse, and now we found out secant is the reciprocal of cosine. Hypotenuse over adjacent, good. Or I could say that secant is 1 over cosine, right? Or in your head, I'm going to write it with words. I'm going to call it the, kind of like a shorthand, not really proper math, but the flip of cosine. You don't have to do 1 over a fraction and then flip and multiply. It's like a little messy. So it is the flip of cosine. That's secant right there. All done and happy for us. Beautiful. Last one. We have one more to do. What's the last one we have to do? Cosecant. So cosecant theta. So what's cosecant theta going to be equal to, Danielle? Hypotenuse over opposite. So we could also say it's 1 over what, Selena? So secant was the reciprocal of cosine because it's hypotenuse over adjacent, and cosine was adjacent over hypotenuse. So now we're on cosecant. We said it was hypotenuse over opposite. What is that the reciprocal of? What's equal to opposite over hypotenuse? Which trig function is opposite over hypotenuse? Yeah, it's sine. That's it. It's just sine. Okay? So it's the flip of sine, or 1 over sine. They're reciprocals, or like I said, this is not proper mathematical vocabulary here, but the flip of sine. So that's really what we need to know here. So if you can memorize, these are the values you'll get for sine and cosine. So if you had like a word bank, and they're like, these are where your answers are going to choose from, it's always one of these answers for sine and cosine when you're dealing with the unit circle, and it's positive or negative. So really, you have 2, 4, 6, 8, 9 possible answers. You got a 1 in 9 shot in getting it right. Now, all we have to do is figure out what are my possibilities for tangent when I stack them. For cotangent, they should be the same ratios, really. And then secant and cosecant, those will also be from the same pool of options. Okay? So we're going to write these numbers down, and then we're going to kind of think about how they're all connected to each other. Okay? I'm going to make a little bit of a, I guess, a table to kind of compare them all. So my first column, maybe don't copy the table right away. See how big it's going to be for me, and then decide, okay? So over here, my first column, I'm going to write sine theta. Oh, this pen's not a good one. I should throw this one out. Sine theta and cosine theta options, I'll call it. So sine theta and cosine theta unit circle options. I'm going to kind of disregard the positive and negative, okay? You'll figure that out on your own. The options are 0, 1/2, rad 2 over 2, rad 3 over 2, and last one is 1. Okay, that's the first column. My next column is going to consist of, I wonder which way I should do this better then. Actually, I'm going to do this. If you already, that's what I said, don't copy it right away. I'm kind of changing my mind. So sine, unit, circle, options. The next column will be cosine that goes with it. Cosine, theta, options. Because like when sine is 0, what is cosine equal to? Yep. Let's zoom this out a little. It's too close. So let me fix that. When sine equals 0, cosine equals 1. I just heard that and that was good. When sine is 1/2, try participating, guys. When sine is 1/2, what's cosine? Radical 3 over 2. When sine is radical 2 over 2, Manny, what is cosine? Manny? Not Manny. Marco? You gotta sit up. When sine is rad 2 over 2, what's cosine? Radical 2 over 2. Thank you. Radical 2 over 2, right? Medium goes with medium. When sine is radical 3 over 2, what's cosine? 1/2. Thank you. All right. What about when sine is 1? Jared, what's cosine? Yes. Okay. Next column. Tangent options. Now we just said tangent is really what over what? Good. I'm going to squeeze that over here. It's really sine over, cosine. Now, what's sine over cosine? What's 0 over 1? 0 over 1. 0. 0 over 1 is 0, okay? So little lesson I usually do in algebra with people. If you have 1 over 0 or if you have 0 over 1, really the 1 can be anything. If you have 1 over 0, no, that's undefined. If you have 0 over 1, that's okay. That equals 0. Okay? I'm glad you enjoy that. All right? Please, guys, don't mix those up anymore, okay? All right. So next, I'm going to do the easy ones first. Here, square root of 2 over 2 over square root of 2 over 2. 1. Anything over itself is 1. All right? We just did our little mini lesson. 1 over 0.
Undefined.
There we go. Undefined. Okay. These are annoying. Now, remember I just told you this one trick? The trick is when you divide fractions, you don't need to flip and multiply. We could divide straight across. What's 1 divided by root 3? Well, that's 1 over root 3, right? And 2 divided by 2, the 2's are gone, right?
Mm-hmm.
So 1 divided by root 3 is really 1 over root 3, and it's really over 1. Can I leave an answer like this? No. Do not leave your answer like this. We rationalize, and I promise you get square root of 3 over 3. And I'm going to tie something into it to make it easier to remember, but we'll get there. Here, we're dividing sine over cosine. What's root 3 divided by 1?
Root 3.
And what's 2 divided by 2?
1.
So we're done. It's just root 3. Okay? These are what you need to know for your tangent options. Now, I'm going to throw something else over here. I'm only going to put quadrant 1. This is 0 degrees or 0 radians. Okay, so I'm going to put R for radians here. This one is really going with pi over 6, pi over 4, pi over 3, I'm getting bigger, and pi over 2. Now, those are my sine, cosine, and tangent options. Keep building from there. Tangent, the buddy is cotangent. Now, I could either say that cotangent is cosine over sine and divide all over again, or I can remember it's really 1 over what? Or the flip of what? Who is cotangent the reciprocal of? Tangent. It's the flip of tan. The, should be theta there, flip of tan theta. Let's make our life easier and just flip the thing next to it. What's 0 flipped? 1 over 0. Undefined. What's 1 flipped? 1. What's undefined flipped? 0. Radical 3 flipped will become 1 over radical 3, which is really equal to what? Yep. I don't care what's in the radical. The reciprocal of radical smiley face is radical smiley face over smiley face. Whatever it is. So over here, the square root of heart. The reciprocal will be square root of heart over heart. Those are reciprocals of each other. When you flip, I promise, don't waste your time rationalizing your denominator every single time. Okay? So what's the flip of this? It's a two-way street, so, yep, radical 3, done. These are your possible answers to trig questions here, okay? Next, I'm going to do secant. That's already theta already. Secant theta, and then last is cosecant, which is each a flip of someone, right? Secant is the flip of who? Cosine. Look at my cosine column. What's the flip of 1? 1. There's not one person in this class, guys. All right, this one you actually have to do the work, but you're going to do it one time and never do it again. Marco, what's the reciprocal of 2 over square root of 3? Rationalized. I don't want to write it like this. If I rationalize it, what's my answer? Miranda? 2 radical 3 over 3. You multiply on top and bottom by root 3. We get that? I'm even going to scribble this out. I don't care about this. Okay. Again, we're doing the reciprocals of cosine right now. That's what secant is. Next, what's the flip of radical 2 over 2? Think about it. It's like the heart question. Kate, what's the reciprocal of radical 2 over 2? Nope. Reciprocal has nothing to do with negatives. What's the reciprocal? That's where we flip it over. Right, but I just went over this trick. These are reciprocals of each other. So, just radical 2. Save yourselves time. Next, what's the reciprocal of 1/2? What's the reciprocal of 1/2? 2. And what's the reciprocal of 0? Undefined. Okay, cosecant. So do you see the symmetry when you set it up this way? These two columns are flips of each other. Then this and this are flips of each other going down. Then the outside two are flips of each other. How else do I have them organized? Sine and cosine are together the co-functions. Tangent and cotangent, secant and cosecant. They're with their co-functions. You'll learn about those later. All right, cosecant, what's the flip of 0? What's the flip of 0? We just talked about it. Undefined. What's the flip of 1/2? 2. What's the flip of root 2 over 2? Radical 2. What's the flip of root 3 over 2? 2 radical 3 over 3. It's right there. Do you see where I was just pointing? It's this. We just did it before, right? And last, what's the flip of 1? What's the flip of 1, guys? 1 over 1 flips, and you get 1. Come on. Okay. Now, this table is what you're going to want to have copied down. Can I have that pass? This is what you want to have copied down. Now, you don't want to look at this when you do your questions. Honestly, you need to just know. You shouldn't have to look up that 8 times 4 is 32 every time you do 8 times 4, okay? When you know an answer, you just know an answer. So when I ask a question, so did we all copy this yet, or are we working on it? Kate, do you have this copied down? Okay, so you guys should be copying this down somewhere. When you're asked to find the sine, the cosine, or the tangent, the secant, the cosecant, or cotangent of an angle, if you know, okay, I want, for example, I'll move this paper in a second. Say I need the secant of 5 pi over 6. Do I know where 5 pi over 6 is in my head? Yes, it's right there. I know it's here. Secant's the flip of cosine. What's cosine at this spot? No, cosine's the x value. Negative radical 3 over 2. That's cosine. Secant's the flip of cosine. So what's the answer to that question? Negative 2 radical 3 over 3. Done. That's it. Okay? If I ask you for the cotangent of 2 pi over 3, do I know where 2 pi over 3 is? It's here. Cotangent. Now, the way I do the cotangents, so this is the last thing I'm going to show you guys, but it does take practice, all this stuff. The way I do them, do you see how this one ends in a 6, this angle? And I think of sine, cosine, and tangent as the original 3. The original 3 amigos. If it ends in a 6, the tangent has 2 3s because 2 3s make 6. Is this true? 3 plus 3 is 6, right? So tan is root 3 over 3. Okay? So I'm not going to post homework, but I want you to know these. Try to memorize this table. Copy it. Take a picture of it. What did we say about class on Thursday? You're going to be on time. You're going to take out your notebook, be super polite and nice and well-behaved to the demo lesson teacher. Please and thank you.